Hello, I'd like to do the test procedure for week 7 forces. Here's the test bench. Check it out. It's a flat piece of wood with a dial. We have pulleys coming down which hold weights. This piece here is a dial of degrees. So we start at 0 degrees, 90 degrees, 180 degrees, 270, a 360 degree dial. What we've got here is just basically a little metal circle, and what we're going to do is put weights on the end of these, so down here, and that will pull this circle away from this middle piece of dowel here. We're searching for equilibrium, where the sum of all the vector forces equals 0. This is demonstrated when the little metal ring is floating, perfectly centered around the piece of dowel. We're going to use a portable electronic scale, this guy here, and we're going to measure how hard we have to pull this piece of wire here in order to make this metal circle sit right in the middle, and that will give us the angle of our force vector, and it will also, by reading how many kilograms we have to pull it, it will give us the force. So we'll get the angle of the vector and the weight of the vector. This is the worksheet. I'm going to set up the test bench for this experiment here, using 3 force vectors, and we know that one of them is 3 kilograms, the other is 6 kilograms, and we don't know how much that is yet. I'm going to set up this test bench with these pulleys with the weights that have been designated in the system forces times 3. I've made this 90 degrees. It doesn't have to be 90 degrees, but I've just said, let's make this 90 degrees. The purpose of this experiment is to find out what this force vector is and what angle it is. Okay, let's do it. I'm going to load this guy up, which is this guy with these 500-gram weights. 1 kilogram, 2 kilograms, 3 kilograms, 0 degrees, and it's 3 kilograms. All right, I'm going to load this second pulley up at 90 degrees with 6 kilograms worth of my 500-gram weights. 1 kilogram, 5 kilograms, 6 kilograms. The first pulley, which is at 0 degrees, has 3 kilograms on it. The second pulley, which is at 90 degrees, has 6 kilograms on it. The purpose of this experiment is to establish how much force I have to pull this string with, at what angle, in order to make this little metal ring here move into the middle. We want to know how much force we need to pull this string out with and what this angle is here in relation to 0. This is 0, this is at 90, so what is this angle here? 233 degrees. Shall we say 6.9 kilograms? 233 degrees. And this weight that we exerted on it was 6.9 kilograms. Let's go through another demonstration of the same setup with different weights to make it clear. I'd like this force vector to be 2 kilograms, 0 degrees. This force vector, 110 degrees, 1 kilogram of weight on it. We want to know how many kilograms of weight do we need to pull this force vector at, and at what angle, in order to reach equilibrium and to center this metal ring around this piece of dowel. So we'll make this one, which is the 2 kilogram weight, at 0 degrees. So we're going to move this pulley here, which is the 1 kilogram weight, to 110 degrees. So 90, 100, 110. This could be any angle. I've just plucked 110 degrees out of the air for us to experiment with today. So 2 kilograms at 0 degrees. 500, 1 kilogram. 500, 2 kilograms. 1 kilogram at 110 degrees, 500 and 500 grams. I'll just chuck that on. We're going to figure out how much weight we have to put on this piece of wire here in order for this to float right in the middle of this dowel, and we're going to figure out what angle it's going to be at. This is just a portable electronic scale. I think it's the kind of thing that you weigh your suitcases on back in the days when we went travelling overseas. So I'm going to pull that nice and hard. Just make sure that's on 0 degrees. The weight measurement is 2.05 kilograms and the angle 208 degrees. When you do these experiments or any of the other experiments that we've been doing physically, there'll be an experimental error of 1 or 2%. When you work these problems out with trigonometry, you'll get a much more accurate solution.
There's a real-world application. In the pallet racking system there, you could resolve the load on the cantilever arm going back down to the column through a brace, and so that's exactly the same situation that's in the workbook.
This is the second part of the step 2 of the tests, which is the system forces with 4 different forces acting on it. As demonstrated here in this diagram, at 0, I have a weight of 3 kilograms. At 120 degrees, I will use a weight of 2 kilograms. At 290 degrees, I'm going to use a weight of 2 kilograms. What we'd like to find out is how much weight we have to exert on this wire and at what angle are we going to be pulling it. So I'm just setting this up, adding an extra vector. So we now have 4 bits of fishing line coming off this ring in the middle. I'm going to connect this ingenious little thing, and that will hold our next set of weights. And this one here is for pulling. 2 kilograms. 3 kilograms on this guy at 0 degrees. 1 kilogram, 2 kilograms, 3 kilograms. And 2 kilograms on this guy. 1 kilogram, 2 kilograms. Make sure it's nicely in its little pulley. Yep, lovely. Right, let's get the angles. We've got the 3 kilogram weight at 0 degrees. Lovely. We've got this 2 kilogram weight at 120 degrees. 90, 100, 110, 120 degrees. So let's move this. Oh, it's hard doing it with just one person. You guys would be in groups if you were doing it. That's pretty good. A little bit of experimental error. This guy here will be from 0 all the way around to 290 degrees. 270, 280, 290. It's pretty good. I'm pulling the scales attached to the fishing line and adjusting the angle at which I pull until the metal ring is floating in a central position around the dowel. The results are 176 degrees and 2.9 kilograms. It says 8.7, I'm going to round it to 2.9. Experimental error. Who's counting? There you go.
Okay, so let's draw one of these examples in Rhino and we can work it out using trigonometry, or we can work it out using Rhino. All right, so going into our polylines, I'm going to go on my vector 1 layer, and I'm going to start at 0, 0, 0. This will put me right in the middle. Now, I want to be 2,000 grams long. So 2,000, that's how long my vector is. If I hold Shift, left click, and then right click, and I end up with a line that is 2,000 long, 2,000 millimeters long, and it's at 0 degrees. Now, my next vector, another polyline, and I'm going to start at 0, 0, 0. This time I'm going to draw it straight up vertically. I'm going to make it 1,000 long, so I'm typing in 1,000, press enter, hold shift, left click, and then right click. And you've got your curve, your second curve. So now, using gumball, this little angle thing, I'm going to rotate this line around to be 110 degrees from 0. Now, notice that the arrows are going this way. We want the line to rotate in the opposite direction, in this direction. So we're going to write negative 110 degrees. Press enter. And there you go. It's gone into 110 degrees. Let's put him right in the middle. Now we're starting to look like the force diagram that we drew. Here's our first angle, here's our second angle. Now we're looking for a third angle coming off here. We don't know what angle it is, and we don't know how big it is. So how do we do that? We grab this guy here. Now this is one I prepared earlier. What we want to do is we know that this force goes up like that. We know that this force goes in this direction. So what we do is we put this force on top of that force. So we've got this scenario where it's top to tail, end to end. Now, by drawing a line from here to here, we can figure out what angle this is and how long this is. So let's just copy that, holding down Alt and moving along. We can copy that guy really quickly. Let's move this vector, this second vector, into its original place, and now we'll move this third vector into its original place. There we go, starting to look like our vector diagram again. Now, what we can do, I'm going to go into the annotations layer, going into dimension up the top. Now I'm going into angle dimension. Now, the line of the first arc is this guy. The line of the second arc is this guy. What do we get? 110 degrees. Okay, so dimension, angle dimension, and now our first angle is this guy, and then our second angle is this guy. Notice I can get each side. And this guy is 210 degrees. Interesting. Our physical experiment turned out to be 208 degrees, so it's in the ballpark, very much so. Let's see how long it is. In dimensions, go to aligned dimension. We know that this guy here is 2000. Right click and we get the same function again. Now we know that this guy here is 1000. So another right click and I'll get another dimension function. Let's see how big this guy is. 1,906 units, like grams. So you would exert 1.906 kilograms on this vector to keep this point here in equilibrium. And in our experiment, we had 2.05 kilograms. So that's not far off either. There you go. Good luck with that, guys.